I still want to challenge you on this one, though. You're saying this is not an isosceles trapezoid? All right, so I want you to investigate that because it looks an awful lot like an isosceles trapezoid to me. So investigate that and see what you think. And because I think that my thinking about this is that the not isosceles trapezoid is very, very difficult to make. And how did you put the two diagonals together here? What was the configuration?
Well, I've got non-isosceles trapezoid, or at least it's supposed to be. Right here.
He's the big one, the small one, like this.
Okay, so I'm trying to figure this out here. So the big one. So could you show me?
We got this here.
Okay.
And we have this over here.
All right. And what you're saying is that this one is, these are parallel.
Mm-hmm. Or at least they're supposed to be.
This is interesting. Very interesting.
And so,
very interesting. All right. So where are we here as a group? What's your next step?
Are we allowed to make a deltoid, or is that?
No, it's concave. Yeah. So that was just on our paper, and I didn't wipe it out. Yeah.
So, like, what we've been working on so far is working off of a rhombus. Because off of a rhombus, off of using these two, we've made quite a few observations off of that. And right now, just right before you got here, we were trying to prove why some of them work off of a rhombus but not a kite.
Huh. And what's the difference between a rhombus and a kite?
Well, this is a rhombus, it's straight, and then all the rest of these, this one are kite.
The difference is that these sides in a rhombus will all be equal length, but with a kite, only is it adjacent? What's the term for the sides that are right next to each other? What's the...
No, but we only need one step.
Do you know the term for when two sides are adjacent? Oops, I said it. I didn't mean to. Oh, my bad.
You gave it to us.
All right, so here's the question I have, and that is do you think a rhombus is a special kind of a kite? So, and I want you to refer to your definitions, just so make sure we clarify that.
It would be a kite where all the sides are congruent.
So you're thinking a rhombus is a special kind of kite?
Yeah, kind of like to have squares, a special kind of rectangle.
Okay, let's see what everyone else thinks about that. Could I please talk to the facilitators for a couple minutes up here? Just the facilitators. Process, because there is a next step, and the next step is to do this. So for each of these things, how did you convince yourself that you were positive about how to make that particular quadrilateral? How would you convince a friend, which would be each other, and then how would you prove it to a skeptic? So do you think your groups are ready for this stage?
Well, we're kind of unsure on what we're supposed to do. Are we supposed to make a conclusion for each quadrilateral?
If you can.
Okay.
If you can. So what do you think about your group?
My group has like every single form of shape, so we're ready.
Okay, and I just talked to your group. And what do you think, Jill? Okay, all right. So I'm going to stop everybody for a sec. Thank you very much. Actually, would you go back and ask your groups to stop talking for a sec so I can give them the directions?
Is this side parallel to that side?
See, we just can't prove that this side right here is parallel to this side.
I think so.
Why'd you just draw?
No, it's not.
Oh yeah, I should just draw it.
I think you have to use two blue ones.
I think so.
I think you have to use a short and a...
I think so too.
Haha.
How did I do that one?
Just do like this.
Oh wait, no. Hold on.
No.
Is it?
That's one way. You can.
Oh, it's deeper.
Oh wow.
I think it just depends on how you make these angles.
Oh, it's like this. Isn't it? Aren't these two parallel here?
That's like what I was saying. They're just very far apart from each other. Oh wait, no.
I don't think those are parallel.
Cause look, wait, but then like that. Do you think it's the same slope?
It looks like it, but
I know, it really looks
Don't
like.
those lines look parallel? A short one and a long one?
I know, but like what position were they
Oh,
in?
no, I'll show you.
How'd you make that?
Like this.
I did it just to like.
that does look like
parallel
them.
lines are
I think like they have to like be.
These have to be congruent,
Yeah.
so it could be
They have to
blue
be at
and
the
pink.
same wall.
I know, that's how mine was. It was like
I know.
that.
So then it can't be the two blues then. It can't. So yours is right. It can't be the two blues. It has to be a blue.
But
and
first,
pink
wait,
one.
how do we prove that? Okay, so we can prove that parallel lines are congruent if alternated interior angles are congruent. And
The two segments.
so if we just drew a random, like, transversal, we have to be able to prove that this is congruent to this and this is congruent to that, and then we can prove that these two lines are congruent or parallel. Do you have a compass?
Oh, there's one up here.
I don't know how to use these.
Right here. Make sure it's straight along the line.
So it's like 123 degrees. Okay, so that's 123.
Yeah, it's pretty much what the said.
Okay, is that it?
Yeah, but how do you explain it? Like
These dots have to be congruent. Like,
this one and that one.
doesn't have to do with the dots. It has to do like the length. Like the length of the top two segments of the diagonals have to be congruent. This
Yeah.
part and this part. That's for this thing. Okay, well.
I don't know how to.
No, because
how are we
see,
gonna
this
write
one
that
has
down?
3 dots and this one has 2, but then the length of they're
But
both
look,
congruent.
but look, if you put them next to each other, they're not congruent like that.
The dots don't really matter. It's
Yeah,
like-
it does.
Wait.
well, look, these are congruent, 4 and then 3.
Yeah, that's what I'm saying. Like
This right here, if you block it off, these two are congruent. But
we
this
did
one
it
has
like
2 dots.
that.
It has 2 dots.
So then the segments have to be congruent. It's not about the dots. Then.
Yeah, I think it has to do with the segments, not really the dots. I think the dots are just there for reference.
Well, then if they're congruent, then suppose it goes like that. It doesn't reach on the dot. Does that make a trapezoid? Because they're not lined up.
Wait, let me see how I did mine. We have to figure out some sort of property to say that.
Facilitators for a couple minutes up here.
Because you matched it up with the dots.
Because you told me to.
Right.
Do it.
Is that me?
Yeah.
Oh, but no, it doesn't have to be Annabelle. So what do we write?
I think we should just write what we think about it, like mathematically, not going with it.
So tell me why you were worried about those dots. For what purpose was that?
Because a lot of the things that we wrote had to do with like the midpoint. So like,
So we don't know if we should go by what the dots are telling us or by what, like mathematically.
What does the dots tell you? I just want to. What do they tell you in terms of
They break the entire segment up into parts.
Okay. Is there another way of doing that without using the dots? Is there another tool that you could use? Because this dots, basically you say that there's more dots on this side than there are on this side?
No, so this is the midpoint.
Right.
So,
I got you. Yeah, so I'm just saying if it's crosses here,
These two don't look congruent. They have the same amount of dots.
Look, the dots do matter though.
but so what is the length from here to here versus the length from there to there?
She said to stop talking.
Why?
I don't know.